A DC, direct current, generator is a device that converts mechanical energy into electrical energy. It operates based on the principle of electromagnetic induction, discovered by Michael Faraday in the early 19th century. Electromagnetic induction, when a conductor, such as a coil of wire, moves through a magnetic field or experiences a change in the magnetic field, a voltage is induced across the conductor. This phenomenon is known as electromagnetic induction. Faraday's law, the induced electromotive force, EMF, in a conductor is directly proportional to the rate of change of magnetic flux linkage through the conductor. Fleming's right-hand rule. This rule helps determine the direction of the induced EMF or current in the conductor. If you point your right thumb in the direction of motion of the conductor, and the fingers point in the direction of the magnetic field, then the extended palm represents the direction of the induced current. Based on these principles, a simple DC generator consists of the following essential components. Stator. The stator is a stationary part of the generator and typically consists of a permanent magnet or an electromagnet. It produces a constant magnetic field. Rotor. The rotor is the rotating part of the generator and usually consists of a coil of wire wound around a central shaft. As the rotor rotates, the coil cuts through the magnetic lines of force produced by the stator's magnetic field. Commutator. The commutator is a cylindrical arrangement of metal segments mounted on the rotor shaft. It ensures unidirectional current flow in the external circuit. Brushes. The brushes are stationary contacts and they provide electrical connections between the rotating coil, rotor, and the external circuit. Working principle. When the rotor of the DC generator rotates, the coil on it cuts through the magnetic field produced by the stator's permanent magnet or electromagnet. As a result, an EMF is induced in the coil according to Faraday's law of electromagnetic induction. The direction of the induced EMF alternates as the coil rotates, which is where the commutator comes into play. As the coil reaches a certain position, the commutator segments reverse the current direction in the coil, ensuring that the EMF always flows in the same direction in the external circuit. This creates a unidirectional current flow, generating direct current, DC, in the external circuit.